Good day, sir. I am the next reporter from the description and uses of bituminous binders. My report is the continuation of that topic. So my topic now is emulsified asphalts. Emulsified asphalts are produced by breaking asphalt cement, usually from 100 to 250 penetration range, into minute particles and dispersing them in water with an emulsifier. They remain in suspension in the liquid phase as long as the water does not evaporate or the emulsifier does not break. Emulsions therefore consist of asphalt, which makes up about 55 to 70% by weight, water, and emulsifying agent, which in some cases also may contain a stabilizer. Asphalt emulsions generally are classified as anionic, cationic, and non-ionic. The first two types have electrical charges surrounding the particles, whereas the third type is neutral. The anionic and cationic asphalts generally are used in highway maintenance and construction, although it is likely that the non-ionics may be used more frequently in the future as emulsion technology advances. Also, each of these categories is further divided into three subgroups based on how rapidly the asphalt emulsion returns to the state of the original asphalt cement. These subgroups are rapid setting or RS, medium setting or MS, and slow setting SS. A cationic emulsion is identified by placing the letter C in front of the emulsion type. No letter is placed in front of ionic and non-ionic emulsion. For example, Cr2 denotes the cationic emulsion and Rs2 denotes either an ionic or non-ionic emulsion. Now let's look at the use for emulsified asphalts in general. Emulsified asphalts are used in cold laid plant mixes and road mixes mixed in place for several purposes, including the construction of highway pavement surfaces and base and surface treatments. Note, however, that since ionic emulsions contain negative charges, they are more effective in treating aggregates containing electropositive charges such as limestone, whereas ca- cationic emulsions are more effective and electronegative aggregates such as those containing a high percentage of siliceous material. Then let's forward to the three grades of high flow, medium setting, anionic emulsions designed as HFMS have been developed and are used mainly in coal in hot plant mixes and coarse aggregates seal coats. These high float emulsions have one significant property. They can be laid at relatively thicker films without a high probability of runoff. Now, let's move on to blown asphalts. Blown asphalt is obtained by blowing air to the semi-solid residue obtaining during the latter stages of the distillation process. The process involves stopping the regular distillation while the residue is in the liquid form and then transferring it into a tank known as converter. The material is maintained at a high temperature while air is blown through it. This is continued until the required properties are achieved. Blown asphalts are relatively stiff compared to other types of asphalts and can maintain a firm consistency as maximum temperature normally experienced when exposed to the environment. Now, the use of blown asphalts, Generally, it's not used as paving material. However, it is very useful as roofing material for automobile undercoating and as a joint filler for concrete pavements. If a catalyst is added during the air blowing process, the material obtained usually will maintain its plastic characteristics, even at a temperature much lower than at which ordinary asphalt cement will become brittle. The elasticity of catalystacy, ca, the elasticity of catalytically blown asphalts is similar to that of rubber, and that is used for canal lining. Now, next is road tars. Tars are obtained from the destructive distillation of such organic materials as coal. Tars are now used rarely for Harvey pavements. Their properties are significantly different from petroleum asphalts. In general, they are more susceptible to weather conditions than similar grades of asphalts, and they're set more quickly when exposed to the atmosphere. The American Society of Testing Materials, or ASTM, has classified road tars into three categories based on the method of production. There are gas hose coal, coke oven, and water gas. Next is property of asphalt materials. Consistency, aging, and temperature sustainability, rating of curing, resistance to water action. So these are the four. And next is the end. The next reporter will continue my report, which is the properties of basta materials. And that's all po. Thank you.